Hello everyone, this is User, and in this video I'm going to solve some LeetCode problem. Today's problem is counting bits problem. It's an easy problem. Let's go through the problem. So we have integer number as an input, and we need to create some integer arrays. The length of these arrays is n+1, and each of the elements of the arrays, the element is I. We can add the number of ones in the binary representation of I. So, for example, in this case, let's see, there's a 2, and the binary representation is 1, 0, and it has 1 eyes. And here, the number 5 binary representation is 101, and it has 2 1 in it. So let's write 2. Okay, so I will try to show 3 solutions, and one is some elegant solution, and the other two, the first two, has same idea behind of these solutions. And the idea is that okay, we get the number, the I, and we just somehow create the binary solution, binary representation of it, and just counting the numbers. Okay, but if we had a decimal number, how can we create some binary? For example, there is number 13. Okay, so we need to play with the divide this number by 2, and playing with the modulo by 2. Okay, so at first we just need to use the modulo of it. So 13 modulo 2 is 1, and then divide the number 13 by 2, it's 6. Then modulo 6 modulo 2 is 0. Then 6 divided by 2 is 3. Then 3 modulo 2 is 1. And 3 divided by 2 is 1. 1 modulo 2 is 1. And we just divide 1 by 2, it's 0. And if you want the binary representation of 13, we just need to read it backward. So it's just 1 1 0 1. But in this case, it doesn't matter the order, but only the number of the ones. Okay, so just start to create the solution. At first, we need to create an integer array as a return variable. It's and the size is +1, and just return this. Then we go through the element from 0 to n and inclusive. So what we need to do? We need to do as I described. We need to create a loop and do the same solution, and we go into the loop until is, let's say, this number is bigger than 0. It's 0, and we just work with it. And we need to another integer use to count the number of the ones. So what we need to do, we need to check the modulo. This is 1. Then we need to increase the counter. If it's 0, we don't need to do anything. Okay, and need to divide the num by 2. And if we go through this loop, then we need to add this to the result. So this is the first version. I hope it's been working. Let's check it. Is there any error? So the thing, let's just submit it. Okay, so it's working. So this was the first solution. It's some intuitive solution. The other solution is similar, but we just use we just calculate the binary representation of number in a different way and counting it in a different way. Okay, so just create a comment. Okay, so first from the number we create some string solution. Okay, and integer object. There's a static method called string. So it will be convert the decimal number to a binary and put it in the string. And then if it's a string, then okay, so there is a method called cars, and it's create an int stream from the string. I mean the ASCII code. Every characters is put in the stream. Okay, as an integer. So we need to clear the from the number. Okay, the numbers equal with character 1. It's ready. Just count. And this one is right along. Compare. Okay, and one thing we need to do is we just cast it. Just check it, it's okay. Not. There's an issue. And it's okay because we use this and then we use this. I don't know. And we the code. Yeah, it's so slower. It's a slower solution. It's a valid solution. Yeah. And the last solution is, as I said, it's kind of elegant solution. It's just go through how is it working. Okay, this in this solution we use the same thing. I mean, we need to divide by 2 and use the modulo 2 of the number. Yeah, so if you see this example 2, we just check. Okay, the number 4 and number 5 is almost similar. I mean, almost similar to number 2. All of them is starting with 1.0 solution. So if we have already calculated the result of number 2, then we need to add only last digit of this binary representation. And as you saw in my previous example, I mean the first example, when I just created a binary representation of 13, I just mentioned that I needed to read backwards. So this 0 is just the modulo, so the modulo 2 of this number, of the current number. So 4 modulo 2 is 0, 5 modulo 2 is 1. So this is the simple one. So the result I is equal the result of the I divided by 2, because in this case it's always 2. In that case, we need just add parentheses just to see what's going on. That's it. Let's check it. It's working. Not. It's really working. Oh, I didn't get any timeout. Okay, just start to check what's going on. Okay, so it's working. Just some issue with the server. Let's submit. So it's working, and it's so much faster than the previous solutions. Yeah. Okay, so that's it.